I think it should be done. Yeah. Does it have like okay, and then to jump out, but it doesn't have to be like so. It should create a new particle. So you're gonna have original particle, new particle, and then you consider and like it should get our not signature, but new particle, like probably. So the second can it use the ventures? So if it jumps in the file, we create some problems. For example, we just classify. So this what happens if you press the next tab, for example, it moves the row which is here into this. So insert this. So the probability is going to be like random floats and take them logarithms. It's going to mean it's the float or something. So this part is going to be and so from this point we should get the outprint of the original one if we want to see where the derivative exactly. And then the new one, but it seems also that it can enter this room, for example, here. Makes sense. And like compare. Some probability. Yeah, because this is yeah, it's like the right spot. Yeah, but it's not gonna work like that because if we're gonna check only for particles which are like smaller than the V probability, we're not gonna like see out the particles which are wrong. So if you're gonna check for particles which are wrong, then we should do here for while loop, then here we should enter the code which gonna like take those particles the if statement. definitely it should one particle, but some of them should be
Right.
like kind of the
So
same.
like, see this one, this a new particle using the original particle as a template. So that makes one particle and then adds it to the array list, the new array, the array list each time. This is add it to the array list.
So is there should be like some sign of like operators which should like be the rules for the X floats which gonna be seed into the new particle. I don't know how did it sound.
So that's yeah, like this gets a new integer, a new float. It uses that to figure out, and that's the number we're using to figure out how many particles to look through before we stop.
And then some probability is like a state value. The sum of probability is still gonna be one all the time, right?
Yes.
So sum of the B, like sum of new float should be like from 0 to 1.
Yeah. B will be a number between 0 and 1.
Yeah.
Let's say it's 0.7. And then you want to keep going through the particles till you get to, enough. You go through enough particles that their probabilities add up to 0.7. And then you want to stop and add that particle to your array.
Okay, I see. So this is always going to be 1.
Yeah.
And then while this is still 0.1, 0.2, whatever, until it gets to 1, then it stops.
So this should always be 1. This will should start to be 0.
Oh, it starts out at 0.
And then we add this. This will be increasing
It
until
cannot
we
be
get.
greater than 1.
Yeah, it can't be greater than 1. Eventually, it'll hit this point.
Which is whatever random 0.
Yeah.
Something.
Okay.
I think we are missing some code in the for loop. In the while loop.
Yeah, let's say, we got index and I. So index was used earlier as just as a random particle,
Oh, right.
and I is the one that you're going to here. But I think you're going to want another one here, or else reuse index. But I think, like in this while loop, you want to whatever. See, you want something like I, but not I, that you keep adding to in this while loop. Your own version of I.
And you can put any other.
But this is the particle in the list, right? Each time.
No, well, yes, but we don't want to do. I mean, we just want to do. If there's 1,000 particles, we just want to do this 1,000 times. We don't want to do it for each particle. We just want to do 1,000 if the equivalent to as many particles as there are.
I don't understand why we would be getting it.
I think I got it. As it should be something like gap sorting. Like gap sort.
Okay. Yeah. Where you find you go through and you find the right spot to insert it in.
I think so. I think I have that.
There's too many things I don't understand.
Maybe. Let's try this. Let's see if this makes sense. Let's try making a new method up here to find a random particle.
This is what we have to get
Okay.
there.
And return a random particle number. Okay? So why don't you just create a public void, a public int. And random particle, or yeah, fine, yeah. Yeah, right.
Does it have the column here? Kind of.
And you don't. Yeah, maybe something kind of like that. Okay. So, and then, so now down here, if we could find a random particle correctly. Okay, so let's move this out of here, this out of here. And put that up here. Eventually, that doesn't want that. Okay. So that, let's just assume that find random particle is going to work. Find us a random particle. Okay. So, let's say here you said index equal to find random particle. Okay, so rather than before we were always just setting it to a random number here, rather than that, we'll just call your new random number thing, set index to that. And then you'll grab that particle, copy it, and add it to or you'll locate that particle based on its index, copy it, and add it to the array. Okay? So if we can get find random to work, does this make sense here?
Sort of. More so than before, I guess.
Right.
But
Yeah. So now, oops. Oh. Yeah, we have an extra bracket. We need a bracket. Okay. So now here we just want to somehow find a random particle list. And here we should probably take this so that this variable too. That's it. So, and you don't need to use this code, but somehow you need to write some code. And basically you want to pick some random number, like 0, like some probably like 0.8. And that's what B would be. And then you want to keep summing up the probabilities until you get above that 0.8. And then you want to return that index.
So why do we put the B equals random next one into the for loop while float is going to create a new float every time we then sum it up?
Well, there's no for, there's just a while loop here.
So do we put the B random next float into the while loop and then
No, you can just have it up. So why don't you look at that? Try to see if you can write that method. See if that will help.
particles for the particle particle.
Yeah. And the particle is a random mass. So
But that's I didn't think that's not the particle. That's something else.
it just random. But before here, it's in this particle. So
This is
so
Yeah, this is, I guess this is what she said.
I don't think it can do integer b because otherwise it's not going to be like.
well, they got rid of all the errors.
It's like not gonna sum up to one.
I know, but it wants it to be an integer. It won't take anything but an integer.
Yeah, if you do like this,
Yeah.
if you're gonna put
But once it makes a map, it should it automatically drives around. Yeah. I got the upstairs map, so
Then what?
third floor,
Like
but I'm
this.
faster. I'm happy to say that.
I'm trying to.
And once you got a map, you can just say,
how to
go to here.
in
Yeah,
like
go to here, go to
to get difference with
those
double.
locations.
Not with
I
integer.
always wanted, when I was in school, I wanted projects with the robots. They only had some funding for it. We had one of those little
Yeah,
Lego ones.
that's what it
So
is.
you could kind of get it to
Right.
use its sensors to understand. how to go
Yeah.
about that.
This actually has a connect and this is a LiDAR unit on top that actually looks around
Wow, that's awesome.
pretty well.
What if you
So
try
between the two, it
find
navigates
one
pretty well.
that-
So. But right now it's not working. I'm trying to figure out why.
I guess there's no support to call for that.
No.
Or-
Yeah. Okay. Yeah. So, thanks.
Good to meet you.
Good to meet you. Adam, was it?
Yeah.
Okay. Nice to meet you. So.
Well, we have to figure out what. I changed the method to that one, so it stops.
Lane switch search up, it leads to the state machine. But so I'm gonna force here. Or alter, right? The one which
It's,
or was it the
sample particles is the method.
and now it's in the random, right?
Average.
Okay, I get it. So that's taking using here some ability, right? If I understand it right, it's a statement which should compare the old particle to the new particle. No?
As long as you're fine when
Well, I don't understand where we're getting it from. Like what the argument is for the, to get, so
Does it go from the
this is the entire list of particle.
yes,
And we're getting the probability from somewhere.
right. So we have to specify index. It's like an array. Like would be like if you are used to doing like this. Does that make more sense to you?
Well, yeah, but we have no eye. You know what I mean, like, I don't know where it's coming from.
So
do we create the array of double random next flow?
So I think you need an eye there. But, so, what we want to do is you want to start out with the zeroth particle and see if that one's going to work. And then you want to look at the next particle, the second, third, the fourth. So you want to start off with I equal to 0. Equal to 0. Okay, so start at 0. And then you want to check, you want to add the 0th particle to the sum and probability. And then you want to see, are we more than B? And if not, you want to add 1 to I each time.
So then you just do an I plus plus.
Yeah.
I changed like it to a double because it was complaining a lot about
Okay, yeah,
stuff.
that's fine.
Yeah.
Oh, wait, no. Okay, there's one thing. So, but what do we want to return when we're done? We need to return new particles. We want to return the index of a random particle, I think.
Yeah, but wouldn't that random particle gonna be a new particle?
No, well, here index is that is a number. So when we go through this loop, so what will be what variable stores the particle
In this loop,
in this loop?
I
Yeah, I.
and some probability. Not that.
Okay, alright. So
No, okay, nothing there stores particle number right now except of some probability. It's kinda.
But what does
Some
I do?
that's what I'm trying to figure out.
Okay.
Okay,
I don't understand what that is.
It's the number which
Try
we
to
gonna
understand
count probability for.
what does this loop do? Try to figure out what that.
It checks the
does.
probability for the value of the.
So I'll let you try to figure that out.
Help me with English. Okay. So I here is gonna change every time and count the probability. So the probability is gonna get higher than the. So I is gonna drop every time. So I just probably return I. And so it's gonna be the number how many times it actually. So first I is gonna be array. So you're gonna get an array I. The I about stuff. You're gonna get the number of this one.
So you're not doing the sum of probabilities.
The some probability as it like it cannot get over the one. Some probability highest small can be one only. So it's gonna like kick out of the while loop automatically. So whenever it's gonna reach the whole number of I. So if you're gonna have 1,000 particles, I gonna run only 999 times of the highest value of I because
No,
the arrays each has 1,000 spots. And when you start from the first spot, it's 0, and then it counts the probability for all of those spots, and gives us, and after that stacks in the array, like each like number of probability, and what's the probability for that to be the right article or wrong. Make sense?
I still don't get it, but
We can
I guess.
maybe if I gotta. So here, whenever we declare I, can you go? Yeah. So we have I, right? It's gonna be so we have an array, which is I hashed named I. So we have first spot, and we start from the first spot, which is 0, right? After that, it goes through this loop, and we get probability for the random number in the I, which is in the first spot. So here we have random number in the first spot. So it runs that all the array the number will have 10 of the particles for the number to be present. So it looks all the numbers and it gets it here. So and it's going to be seen, like for example here for this random you're going to have 0.2 next. So just all the sum there of possibility still going to be 1 complete. Oh, I mean here, sorry. This is 1 max, which is sum probability. And I will return us that number of
Hey, I sent
of
out
the
an email
random
of
numbers which we ran
the
through
IT leadership program is
for that
officially discontinued now. It's kind of mixed feelings.
Yeah, it's hard. Well, I remember when we started that program, we hired you just for that purpose. So hopefully we keep you.
That's what I told my partner. Plenty of other things to do. But it was well received. I'd like to see academic departments actually take financial responsibility or something. So it's like a
Sort
precedence
of,
about
but
doing
I
it.
still.
Do it without being asked to do
Right,
it.
yeah.
So I is just
Good, I got that.
Okay,
done. So I
yeah.
copied you on an email I sent,
okay.
I forwarded an email to you that I sent to the students. There was our,
Okay.
I have like students or
It's just like
something like that. But I sent that to the students to let them know
so
that
every
they're still going
I
to
is
get
the
the
number of how
program
many
and we'll
possible
start this
particles
right.
we have.
So I copied the department and
How many spots in the particle list?
Sounds good.
All right.
Okay.
And Heather looks like she finished up the computer club.
Okay.
Maybe
So
it's
she's
over
in the
the
shape.
But I
Yeah.
don't think
They have the accounting group that
I
wants to
think
use
that's
that.
what,
I don't know what that
This
group is,
I-
but she said some finance people are coming.
Yes.
Yeah.
They
And
use
so-
it for so short term for
Right.
it just so
So I think that's nice.
Yeah, that's good. Right. That support them. So
I is has just
Okay.
like the number.
we'll see it.
it's just gonna go
Yeah, it does.
through, but
It does.
it's not gonna go through the whole 999 thing or 1,000 things. It's just gonna go until
It's gonna get us
till the sum of up to the sum of all these.
Yeah.
Is
until
not
this
more than
one.
whatever not one, but whatever the random full thing is. Because if we're doing it against B, and it's gonna be between 0 and 1, it's just a random one. So say it takes 0.7, it's gonna go through I as many times as it takes to add up to 0.7. What I see on this. Because this is the random one between 0 and 1. So until it's going to keep adding up probabilities for these until it gets to whatever that random number is, and it's going to stop. at this turn. It's just
What did you get from actual equations? I just kept it.
it's still not working. It's not supposed to get rid of all the particles. Right?
No, so show me what you have so far.
So
I guess show me else. Yeah. So show me the code again. Find that. Find that. Awesome. Abilities. I think if you look, it should be going through this list a bunch of times, I think, right away, and it stops, because no, it's okay, some probability is 0, and all that is greater than B, keep going through. We should maybe like start printing off what it returns each time. So it gets the high probability, adds it to the sum.
Like it returns before I plus
Oh, yeah, I think, yeah, because you're returning the next particle. And then down here, one of the problems is that, right, you're finding the random. So, I mean, I would print off what particle it's returning each time. And again, maybe student, once it's, so if it finds a particle, I think you are also going to the next particle each time here. It's like you say, you might want to return.
this return.
Or else what happens if you move this up above this?
But then it wouldn't start from the 0. No?
Right. I guess that. Why? I mean,
I
you're
think
getting
try
all
to
the
do like
exact
this.
same particles.
Try to put return statement every time after this.
Okay, yeah. And I would just try to print off what I is each time. I think you're always getting the same particle every time. I don't know what exactly is going on, but
Yeah, but that's not gonna work. Because you have to have a return statement outside. You have to return something outside.
hi.
Hey, what do you want? There's a DigiKey bag still in the cupboard. What do you want to do with it? Put like a draw on a cup and a shirt.
You should give them away at the land party.
Okay, I can do that.
How about that?
Yeah, and then I grab like some other tables.
Okay.
I'm gonna use this for our table's dirty.
Oh, and by the way, so I think that there was
And you can't have that after.
so that all the particles we have, it says all of them are 0.
So when you print I, it just prints out a bunch of zeros.
So what is the sum of the probability?
We just how many you have? Make a note.
It's the
It's always 0.0.
yeah. So 0.0.
So it's not getting it.
Right. So it's, yeah, I think you want this to be less than b. So it starts off to be 0, and while it's less than, we'll keep adding to it. And eventually, you'll reach it.
Okay, well that's.
I don't think. Let's see. Oh,
I don't know.
yeah. Let's get that out of it. Try that. So now.
That's promising.
Oops.
No.
So somehow you're not getting the index 1,000.
like the house?
Oh, the stables.
Oh. Oh. Man.
There's a
How
bad
you gonna find
stable.
up?
Said it a couple of times.
I think we're gonna, here, it's not, it's just, not initialize that. So sometimes you're finding a thought, I think like if you get the 99th particle, you're adding one to it. So I think you should be in general retention adding -1 because you add one to it here. So we get our particle, we add it to the list, and then we add one to I, and then we find it's the last particle, put it over the list.
This I though goes from 0 until whatever it is less than the random number, right? Is that how that works?
Yeah, but see, like it could be a 901.
But how is it pulling from the 0 through 999 points or whatever? Like, you know what I mean? Like, how does it? Is it because it's going from this?
Yeah. I mean, B should be a number between 0 and 1, and all of these, if we add up all the probabilities, that should also be a number between 0 and 1. So eventually, we should be guaranteed to hit that by the time we get to there.
I think what's confusing me too is just where things are coming from.
Yeah, right.
Look at. You want to see what's done with me? I printed one.
Clumping, sort of.
Something. Looking bad. Let's see. Pretty bad there. You did pretty well there. So. Okay. Oh, look at that. Well, would you have a question?
No, so is that it?
Yeah, that's
okay.
you probably want to get rid of those print statements. You probably don't need those there. So.
And clean up the rest.
Yeah. So.
So what are you using right now? You got it working?
Yeah.
So what was it?
The if then was wrong.
So because it was going past the index bounds of the list. So it was like reached 1,000, okay, it crashed, but we don't want it to go past,
This 1999. Okay.
because it's 0 through 999, not 1,000. So if it gets to
Array list particle now.
where it was turning it into it was initializing it as
So like this now.
so we just got rid of that. And then called it in here with that method.
And expand random.
which is this one.
Did you find random here in the code?
No, we created
Or did you put it?
right before this.
Can I take a picture? This is the second part, right? Or the homework? Or no? No. Is the whole homework?
That's that whole thing.
Okay. Oh, and it works.
So it's getting pretty good by the time. It knows pretty much where it is. There we go. So now it knows where it is. So after about, I don't know how many that was, 10 clicks or so, it knows where the robot is. Oh my god, that was super hard. I still don't
I want
understand
to
all of
actually
it.
ask him the part for better understanding if we can print
And we
out the
changed-
probabilities actually.
Yeah,
If
and
we get to that.
we changed it from to less than that, so it'll add up until we get to that random float, and then it'll stop.
Okay. I think Tom left. No, his plane was the robot. Okay, thank you very much for cooperating. Cooperation.
I just did not understand what was happening.
Like, it's quite a bit weird since, okay, we declare an I, right? And it's still
not really these things.
like, so it's still like weird because if you're getting I, and it
Which
goes
is from which
partial-
can be anything between
Yeah.
0 and 999. And we're adding up the probabilities. of
I
each
still
of
want to
those
ask him
and-
to get the statement to print out the probabilities, how it works, to see like, the wording.
But it's just like how you were saying. So we're printing it's whatever the probability is for all the things in the list up until it adds up until we get to whatever the random float that was picked is.
Yeah, that was our problem. It was getting right, but then it didn't work because of I.
Yeah. Because it was going one more than
Yeah,
what we
because going for the 1,000.
Yeah. Oh boy. That
So,
was
like-
one tough assignment.
Yes, that's what part here. I said it wrong. So this part shouldn't go like take till the one. This
Yeah.
part was like getting all the probabilities and then assigns the values to it after it see all the probabilities. So does it make more sense now?
Right.
Like so
It's
it
just-
get first it figure out all the like degrees which we have, and after that it gets like, for example, number 100 gonna have probability 3, number like 55 is gonna be 0.2. So that's how it gets.
Then it keeps adding up all of those until it gets to whichever thing gets hit there, and that's when it makes sense.
Yeah. For example, it like starts with I, it has 1, so that probability is 1, and then it adds next one. So it like checks which one is bigger. So it like gets 1, for example, it divides 60 by 40, and then it gets 1 more. So it's going to divide it, for example, 40, 20, 20, and like that, and keep going. So that 4 number, 5 number, all the time it's going to add it and divide it.
Yeah, well, like today I'm trying to create a map, and so it has a little problem. Once it has a map created, it can map where the walls are and everything else. It thinks it's you know, it'll just say, oh, that's an obstacle. So that's obstacle. Sure. Okay. It tends to think.
How do you like the test on the data structures?
I didn't get to finish. I ran out of time.
It was actually, I didn't think that I spent so much time on
Not
it.
real about
It was like so fast.
30 minutes is not enough time for those things. It's not enough time. It's just, I told her 30 minutes is not enough time.
And like, so there are women who takes care for international students, because I don't live in the States, I still live in Ukraine. And she went to ask her like if she can give me like a couple extra minutes because I need those time to understanding.
Right.
And that woman said no, because he is sophomore. Like no, that's why he can't do that. Yeah. I got lucky because the last where you had to write a pseudocode for the algorithm. So I was lucky because I had that pseudocode in my notes. It's copy and pasted.
I didn't even get to write anything for that last question. And that was 4 points right there.
It was 4 point?
Yeah.
Oh, then I got 4 point.
You know, so I was pretty ticked off about that.
Yeah, and also I understood a couple questions I did on the first test. So
I gotta wait to see if how some of those, how she grades some of those other ones where you have to write in and stuff. Because sometimes those get marked on by accident. But I hope I can get some extra credit or something somewhere. Cause, that was bad.
I like everything beside the test.
Okay.
Tests with stone was always fun in Joe 1 because we had Zybook.
Zybooks. I wish we still had that because that would be very helpful for the data structures class too.
Yeah, Zybook's actually a good thing.
Yeah, that's the question. So yeah, that's one thing I've been wondering about with using these online textbook is afterwards you don't get it anymore, right?
Yeah.
So
I wish I still had it. Yes.
yeah, right.
What do you mean, like you don't get it?
You only get it for
You rent it out,
you rent and
Oh
then it's
yeah,
done,
like you technically just get the course.
right?
You can pay it again actually.
Yeah, but you,
Like even you're taking your class, you can pay for a year